Today we're going to talk about graphing polynomial functions. We're going to use a lot of the knowledge that we learned in the previous unit in order to graph polynomial and rational functions. So this is the first learning target, graphing polynomial functions. In order to graph polynomial functions, the first thing you're going to want to do is identify the zeros. Zeros are where the graph crosses the x-axis. Okay, so you've done that in Algebra 2. We're going to use the multiplicity of each zero in order to determine if it touches or crosses the x-axis. Multiplicity means how many times you multiply it. If a factor is done an odd number of times, it's going to cross, and if it's an even number of times, it's going to touch, which means so odd is going to be cross, even is going to be touch. An example of that would be something like this. If you had a polynomial that factored to x plus 2 times x plus 2 times x minus 1, if this was your function, what this would mean is this 0 was created by one factor. 1 is odd. That means that the graph would cross the x-axis at that point. Whereas x plus 2 and x plus 2, that's done an even number of times. There's 2 of them. That's an even number. Multiplicity is even. That means it's going to touch, or what I call bounce. And that means it hits the x-axis and goes back the same direction. Okay? We're also going to use the degree and the leading coefficient to determine end behavior. End behavior is what happens when x is extremely large, as x goes to infinity, or as x goes to negative infinity. That's going to be the end behavior, as x gets really large and x gets really small as the x values increase or decrease. And then as you read a graph from left to right, if the y value is increasing, then the graph is increasing over the interval of x values. The opposite is true for decreasing. Okay, so let's look at a few of the examples. So what we're going to do is we're going to graph f of x equals x to the fourth minus x squared minus 30. So the first thing that we want to do is we want to find the zeros. How do we find zeros from our previous unit? What do? We factor. So what we're going to do is we're going to take x to the fourth minus x squared minus 30, and we're going to factor it. This is a trinomial, so I'm going to look at the factors of negative 30 that add up to negative 1, which would be negative 6 and positive 5. Now, we have an x minus 6 and x minus 5, but notice this is x to the fourth, so we would need to break this up as x squared and x squared. Okay? So then what we do is we want to find the zeros. Now, zeros are where the graph crosses the x-axis, which means the y value is 0, so f of x equals 0. So we have 0 equals x squared minus 6 and x squared plus 5. Then we set each factor equal to 0, and we solve each one of those. Just like we did in the previous unit, we would take the 6 and move it to the other side by adding. Then we would square root both sides, and you would get plus or minus square root of 6. Here you would get x squared equals negative 5, square root both sides, and you get x equals plus or minus I square root of 5. Okay? So there's my zeros. X equals plus or minus square root of 6, and x equals I square root of 5. Graphically, the square root of 6 is going to show up. Graphically, this I square root of 5 is not going to show up. We're not going to be able to see this I square root of 5 on the graph. The next thing we're going to want to do is we're going to want to find the y-intercept. The y-intercept is the constant. A y-intercept is when x equals 0. If you plug 0 in for x here, you plug 0 in for x here, you're going to get negative 30. Okay, so the y-intercept is negative 30. Okay. The end behavior, that's going to be done by looking at leading coefficients. And so the way that we do end behavior is we look at what happens when x is extremely small, negative infinity. So what you do is you go back up here and you take negative infinity and you substitute it in for x. Well, negative infinity to the fourth power. Play with 100. A negative 100 to the fourth power is going to be a negative times a negative times a negative times a negative, which is a positive. And then these two over here are going to be so much smaller than this one, it doesn't matter. So all you have to do is look at the first term. Negative times a negative times a negative times a negative is a positive. So as x goes to negative infinity, the y values are going to go to positive infinity, because a negative times a negative times a negative times a negative is a positive. Now as x goes to positive infinity, now again, come back up here, take a really large number, plug it in. A positive times a positive times a positive times a positive is a positive, and it's going to be a really large number. Okay? Then we're going to look for the number of turns. Number of turns, okay, is determined by the degree. The number of turns is always going to be 1 less than the degree. So this is degree 4. So we're going to have up to 3 turns. Okay, up to 3 turns. We don't have to have 3 turns, but we can have 3 turns. So now what we're going to do is we're going to take all this information, we're going to put it on the graph. So we're going to start with our zeros. Square root of 6. Well, square root of 6 is going to be a little bit bigger than 2. So we're just going to kind of come over here and we're going to estimate it, okay? Somewhere bigger than 2. We also have the negative one, so we're going to go somewhere a little to negative 2, somewhere in between negative 2 and 3. Again, these are complex numbers. They're not going to show up on this graph. We also have a y-intercept of negative 30. So we could go by, on the x-axis, we could go by 3. So this would be negative 3. So negative 3, negative 6, negative 9, so on and so forth. Down here, this would be negative 30. So we have a y-intercept down here of negative 30. Then what we do is we use our end behavior. As x goes to negative infinity, what's going to happen to the y values? The y values are going to go to positive infinity. So what happens here is the graph can no longer, the only place the graph can cross the x-axis is right here and right here. So as x goes to negative infinity, the y values are going to go up like this. As x goes to positive infinity, the graph is going to go up like this. Okay? Now what happens in the middle? I'm not exactly sure what happens in the middle. We are looking for a quick sketch. We could have up to 3 turns. We don't have to have 3 turns. Okay? What we do know is that our graph is going to come down here and hit negative 30. So what I'm going to do is the graph goes through this point. Our multiplicity for square root of 6, there's only one of those, so it's going to go through. It's going to come down here. It's going to hit this point, and then it's going to turn and come back up. And it's going to go through that 0. And there is the quick sketch of this graph. Now, if you wanted to, you could go use the graphing calculator and see if that looks similar. Again, we're not looking for perfection. Okay. Now let's look at a different one. Okay. Again, we're going to factor this, so we're going to group the first 2, plus group the last 2, and then we're going to group. So we can take out an x squared, and I'm going to have x minus 3. I can take out a negative 4, and I'm going to have x minus 3. Then I'm going to group by doing greatest common factor, which is x minus 3, and then x squared minus 4, which then factors to x minus 3. This here is a difference of perfect squares, which is x minus 2 and x plus 2. Those are going to be equal 0. So what are my zeros? My zeros are 3, 2, and negative 2. So what I'm going to do is I'm going to come over here and put those on the graph. Positive 3, positive 2, negative 2. Now I'm going to find the y-intercept. The y-intercept is when x equals 0. Plug 0 in, and you're going to get your constant term, which is 12. So now I'm going to come up here to positive 12. I'm going to go by 2 so that I can show it on here. 2, 4, 6, 8, 10, 12. And again, these are going by 2's. Okay? I'm going to now determine my end behavior. As x goes to negative infinity, you only have to plug it into the first one to determine end behavior. A negative times a negative times a negative is a negative. So as x gets really large or really small, my y values are going to go to negative infinity. As my x values get extremely large, positive infinity, a positive times a positive times a positive would be a positive infinity. The number of turns, how many turns am I allowed to have? I can have up to 1 less than the degree. So I can have up to 2 turns. Okay? So now let's go through and put all this information on the graph. We have 3, and we have negative 2, we have positive 2, we have 3. The multiplicity, this is a multiplicity of 1, this is a multiplicity of 1, this is a multiplicity of 1, which means that the graph is going to go through those points. Okay? So in behavior, as x goes to negative infinity. So here's my smallest 0. As x goes to negative infinity, as x gets smaller, what's going to happen to my y values? They're also going to go to negative infinity. So my graph looks like that. as x goes to positive infinity. So go to your largest 0, and as x goes to the right, as x gets larger, what's going to happen to my y's? They're going to also go up. Now, what happens in between? All you're going to do is you're going to go through a usual multiplicity. I'm going to go through this point. My graph has to turn because it has to get back to that one. It's going to go through this point. It's going to come up here. It's got to hit that point, and then it's going to turn, and then it's going to go back down there, and it's going to hit that point. This is a rough sketch. It's not perfect. It does not mean this is exactly what it looks like. We're getting an idea. When we get to calculus, you can figure out how to do it from there. Okay? Let's look at another one. This type of problem here. Again, degree 3, we're going to try to factor this. We can take out an x, and then I'm going to get x squared minus 4x minus 5 with a greatest common factor of x out front. Then I can factor that, and I'm going to get x times x minus 5 and x plus 1. Okay? My zeros would be 0, 5, and negative 4. Oh, excuse me, not negative 4, negative 1. Can't read my own writing. Negative 1. Okay, my y-intercept would be 0 because there's no constant. You plug 0 in up here, you're going to get 0. The end behavior is x goes to negative infinity. You plug a negative in here, and it's going to become a negative infinity because a negative times a negative times a negative. You plug a positive in there, and it's going to become a positive infinity. The number of turns would be up to 2. There we go. Now let's graph our information. We have zeros of 0. We have a 0 of negative 1. We have a 0 of 5. 1, 2, 3, 4, and 5. We have a y-intercept of 0, which is already on the graph. We now take our end behavior as x goes to negative infinity, y goes to negative infinity. So we go from our smallest x down. We go from our largest x up because as x goes to positive infinity, y goes to positive infinity. Okay, now we look at our multiplicity, 0. 0 came from here. How many factors created that? 1. So that means it's going to go through. X minus 5, there's only one of those, there's only one of those. The multiplicity, 1. So we're going to cross. Means I'm going to cross. Okay, I'm going to come up here and turn somewhere. I don't know exactly where. And then I'm going to come back down and hit that point. Okay, I'm going to go through that. I'm going to come down here somewhere and turn. I don't even know exactly where those are at. I don't need to know those right now. We're just looking for rough sketches. And then you have a graph that looks something like this. Use your graphing calculator to verify that that actually is what it is.